Welcome to the channel Physics Made Easy. Today we will discuss again few interesting facts about plane mirrors. First of all, see number of images formed by two plane mirrors. Look, case 1, if the plane mirrors are placed parallel to each other, that is like this. This is first one. Okay, if you write its name M1 and this is M2. If the object is placed, suppose at the point O, okay, equal distance from these two mirrors, exactly in the middle. You know, in the last video we have seen that object distance is equal to the image distance. So by M1 the image will be formed, first image will be I1 at this point at the same distance. Here also at the same distance you mark the image I2 formed by M2. What happens that this I2 will act like the virtual object for mirror M1. Two images, two mirrors, it's all right. But this I2 will act for the M1 as virtual object. At what distance? If this is suppose A, then this is also A and this is also A, then 3A distance. Then from mirror this A and this is about 2A distance. Here its image will be formed as I3. Similarly, this will act at the distance of 3A for M2. This I1 will act like the virtual image, virtual object. So from this position you will find another image I4 at the distance of 2A. Okay, like this here. This will be the distance 2A, this is A, the total distance 3A. Then again this I4 will act like the further virtual object for this and behind it, and this image will act like the virtual object for M2 and behind it. How many images will be formed? Infinite. And falling intensity will be there. First image is I1, then I2, then fall of intensity will take place and you find number of images infinite. How can you show? Look here, for the first image, suppose this is the object, this is the incident ray, normal incidence, so it will be retraced. Now another ray which is at this point for this mirror, okay, you look here that if you find the other image like other ray like this, then what will you find? That this is will be reflected from mirror M1. If extended back, this I3 is formed. Similarly for here, if you see this is the normal incidence, so retrace its path I0 R0 and another ray which is at this time now like this. So it will move in such a way that if it is reflected, then it's supposed to be coming from I2. So it is reflected like this. It is reflected in such a way that it is supposed to be here coming from I2, and this is incident on M1, so it is reflected in such a way that it is coming from I3 and so on. So in this way infinite number of images are observed. What will happen if you see two mirrors? They are placed like this, okay, and the position of object is suppose somewhat here at the point O. This you may say that these mirrors are of insufficient length, object is here. Now still the infinite images will be formed. Can you tell? No. Look what will happen. For this mirror suppose M1, here for this mirror M2, What will happen if you suppose this mirror is extended, then at the same distance here behind the mirror, this will be the image I1, and at the same distance behind the mirror, if you extend it further, then mirror, this will be the I2. If you see that one ray is, again this is incident and reflected back, and other ray is at this mirror at this point, it is supposed to be reflected in such a way that it seems to be coming from I1. So this ray and this ray, two minimum rays are required to form the image. So this is I1. Now in front of this ray there is no mirror, like here in front of this ray there was mirror, then further reflection will take place. So number of images are infinite. Here since there is no mirror, so only this one image will be formed from M1. Similarly here, if this is the incident ray and reflected ray, and if this is the ray incident from the object at this mirror M2, so it will be reflected obeying the rules of reflection in such a way that this is the reflected ray. So these two rays have no further mirror to reflect them, so only two images will be formed. Okay. Now let's see next point. See the relation how to find the number of images. Let n is the number of images formed by the two mirrors placed at the position. Angle between them is theta. What is theta? Angle between two plane mirrors. Then number of images are n. Case 1, if n is even, then number of images are n minus 1. For example, let us take theta equal to 90 degree. For theta equal to 90 degree, n is 4. Therefore, number of images, how many images will be there? 3. Okay, n minus 1, that is 3. Let us see how it happens. Suppose this is the plane mirror first, and at 90 degree perpendicular to it, this is another mirror. Okay, the object is placed, suppose, at this point O. As you know, the distance of object is same as distance of image from the plane mirror. So equal to this distance, you mark the position I1 image by mirror M1. Similarly, at this distance, you will mark the another image. This is called I2, formed by the mirror M2. How this image is formed? You can find the normal incidence, incident ray, reflected ray, here also the incident ray and reflected ray. Another ray which is moving at this mirror in such a way that it is supposed to be reflected like this. Okay, so these two minimum rays are forming I1 here. Here also you can find that if this is the incident ray for this mirror M2, then it is supposed to be reflected. The ray will come from I2 in this way and here. So here you are watching, this is the I position, these two images. Where will be the third image? Look, if you extend the mirrors in such a way that these are the straight lines showing the extended positions of the mirrors M1 and M2, then this I1 will act like the object for extended position of mirror M2. So you mark the distance of third image at the same distance here. So this will be the I3, and these distances will be same. That is, this I2 will be acting like the virtual object for this extended position of mirror M1. So this distance will be equal to this distance. What will you do here? If you find the position of I3, then one ray is coming. Look, this is for I1, I2, it is clear. Another ray you can show coming from O2 in such a way that it is coming at M2 and reflected from M2, it falls at M1. Now it will reflect in such a way, look, that it seems to be coming from I3. So you have to join here and then you will show this is the reflected ray. Similarly, for this one, you can also show that if a ray is coming at this mirror M1 and it will be reflected and it will come at the mirror M2 in this way. Now if you join here, then this will be the reflected ray. Okay. So in this way I3 position is clear. Here I1, I2, I3, three images are seen when two mirrors are at 90 degree. Again, if the two perpendicular mirrors are placed in such a way that the object position is somewhat here. Okay, these are the mirrors which are perpendicular and suppose the object is here at the point O. Now how many images will be formed? Look here. If this is the incident ray at the mirror M1 and M2 as per previous names, okay, then it will be reflected back. If this is the ray which is another ray, then you find that this is the object distance, this will be the image distance. So image will be formed somewhat here I1. Similarly, image will be formed from this mirror M2 as I2. Okay. Then this ray, reflected ray, you have to join this point of incidence from I1 in such a way that this is the reflected ray. Okay. Similarly here, this is the incident ray and reflected back, and another ray you will take in such a way that this ray is supposed to be reflected in such a way. Now there is no mirror in front, so only two images will be formed. Okay. So here if they are placed in this way, three images, and if they are placed having the position of object like this, only two images. Now case 2. In case 2, if n is odd, then again there are two sub cases. If the object's position with respect to mirrors is symmetrical, then n-1 images, and if unsymmetrical, then n. How? Let's case the angle between the mirrors 120 degree. What will be n? N will be 360 upon 120, that is 3. Now how this 120 is? If the mirrors are placed in such a way that angle between them is 120, and if the object position is symmetrical, that is if this is the object here at point O making 60 degree both angular position of the object with respect to mirrors is symmetrical, then number of images will be only 2. Okay. How to find how many number of images will be formed? I am telling you, suppose this is the M1, this is the M2. You know, one image will be formed here at the same distance here, and second image is from M2. What about third? If you don't go for the ray diagram, then how will you find the number of images? You make a cross. Okay. Write here M1 and M2. You know that for first image M1, from M1 it will be behind M1 at the position I1. Okay, so this is angular position of the object, and you will find that the O has its image at I1. So here you will find this is at 60 degree. Okay, same angle behind. Here also from M2 same angle behind will be the image. So this is also 60 degree. This is the first I1 I2 position, and angle between them is 120 degree. Okay, this is between the mirror. Now add these two number, what is this? 180. Add these two number, what is this? 180. If 180 is the position, then no image is seen. Then how many images are there? Only this 1 and 2. Look, if the 180 or more than 180 degree angle is formed from the mirror, then the further image will not be seen. How can you show here? Look here, that from the measured position you will find that this I1 which is acting, which will act like the object for this M2 mirror, at the angle of this will be also 60, and this is also 60, that is 60, 60, 60. How many? 180. So at the position of 180 degree I1 will be formed, then you will find that there will be, look, this is the perpendicular situation, and this will be the situation of, image. And almost if you will measure, then you will find that this will come behind the extended position of mirror, so its image will not be formed. This is I1. Similarly for I2, if you find that this will be the same distance and extended mirror will be here, then this position of I2 will be behind the mirror, so no image will be formed. Only I1 and I2 will be seen, as I have shown here. Now if the same mirrors which are at 120 degree, but the object position is unsymmetrical, that is from one mirror if it is at 30 degree and from other mirror it is at 90 degree, total angle is still 120. How many images will be formed? Look here, that again you make this crisscross method. This 120 degree, this is M1 mirror, okay, and this is M2. You will find here M1 and M2 right here. Okay, this image will be at 30 degree angle behind the mirror, from M2 at 90 degree behind the mirror. Now 120 plus 90, 210, and 120 plus 30, this will be 150. So first, second and third, this 210, this will not be seen because it is more than 180. So what I mean to say, here three images are seen, and as we have found that if theta is 120, then 360 upon 120, this will be 3. So three images are seen, that is equal to n when the position of object is unsymmetrical with respect to mirrors, and n minus 1 when position of object is symmetrical, because for normal incidence we have seen here I1 behind the mirror M2, we have seen here I2 behind the mirror M1. So only two images, I1 and I2, no further image of I1 and I2. So in this way this is calculated. The formula for number of images, n equal to 360 upon theta, and if n is even, then whether the object is placed symmetrically or unsymmetrically with respect to position of mirrors, number of images will be n minus 1. But if it is odd, then we have discussed that if the symmetrical, then n minus 1, and unsymmetrical, then n. Now come to the next point, velocity in plane mirrors. Simple. If this is the mirror, okay, and object is placed at the certain distance, suppose here at the point O, if the object moves towards the mirror with the velocity VO, what will happen? What about its image? Look, at this point O, when the object is here, then as per rule that object distance is same as image distance, so here will be the image. If object moves towards the mirror, then image will also move towards the mirror with the speed Vi. Remember, we have considered the speed perpendicular to the mirror. Since this is the positive direction, so what will you comment? That VO is minus Vi, as velocity is vector quantity, so you will write like this, is it? What will happen if the mirror also moves? Suppose in this case, this is the mirror which is moving in this direction and the object is moving in this direction. What about the image? How will you find the velocity of image? In this case, we will write here velocity of object with respect to mirror, that is VOM. Remember relative velocity. What will you write for this? This is VO minus VM. Okay. Now, if this is the Vi, this is the position image with velocity of image Vi, how to find it? Look, what will be the VIM? You will write here, this will be Vi minus VM. Same rule, that VOM equal to minus VIM. You will apply here. What will you get here? This is VO minus VM equal to minus Vi minus VM. What will you get here? Look, VO plus Vi. Here this will be minus, here this will be plus, minus Vm, this will be 2Vm. So, what will be the image? Vi, Vm, mirror's position. If you find this Vm, then Vm will be Vo plus Vi upon 2. And same case is here. If you put Vm0, you will get like this. In case of any numericals, suppose it is given that this is 5 meter per second. Okay, this is 3 meter per second. Find the Vi. How will you find? Put Vm. What will you write? Not 3. Negative direction. This direction is positive. So, what will you put here? Vm will be this minus 3. This will be equal to Vo. What is given? 5 plus Vi upon 2. This is minus 6 minus 11. Will be or not? So, in this way numerical problems are solved. Look the case 3. In case 3, if the mirror is placed like this and instead of moving perpendicular to the mirror, the object is moving parallel to the mirror. This is VO. Nothing. Same distance will be the position of image. So, here this is I. So, this Vi will be also same. So, what will be the formula here? This VO vector will be same as Vi vector. No negative sign. And also if the mirror moves, then there will be no effect. So, these are the cases. Now, another interesting case. Now, we will see the case when the object moves in such a way that this is the velocity of object. Suppose this is 10 root 2 meter per second, that is making certain angle with the x-axis. Suppose this angle is 45 degree. Okay. If this is the velocity of object, then this is Vox you can write, and here the component Voy. What will be the speed magnitude of image? Find. Then how will you find? With the help of example. You know this is the object, then at the same distance you have to show the image position. And how will you find the image? Look here, that this VO VOX, that is perpendicular component, will be this 10 root 2 cos 45, will it be or not? And this will be sin 45. So VOY and VOX both will be same, because cos 45 and sin 45 both are 1 by root 2. So here you can write VOX equal to VOY equal to 10 root 2 1 by root 2 into, then it will be 10 meter per second. What will be here? The image position, same for parallel case. If this will be 10, then this will be 10. If here this will be the 10 in this direction, then in this direction this will be 10. What will you write for image coordinates or velocity vector? So V image net velocity will be written as minus 10 I cap, if you write in the vector form, the negative x axis, and plus 10 j cap. Look here. Then what will be the magnitude of velocity of image? Then under root this 10 square and 10 square, that is root 200. And if you find these components, they are asked, you will find in this way. What will be the, this is the net VI. If it makes angle theta, then you will find this is 10, this is 10. What will be the value you can find? So we have seen reflection by plane mirrors, number of images, and velocity of moving object in front of plane mirror. I hope you must have enjoyed. Thank you.